establishing a single switched network. So so far we've been using the Ethernet shared what do we call it? We've been using the multi-access network that has a shared local interface. But now we are going now to use a switch, to introduce a switch in our network. So the introduction of switching device, a switching device as part of the enterprise network demonstrates how networks are able to expand beyond point-to-point connections and shared networks in which collisions may occur. So the problem with those shared networks is collisions, number one. So behavior of the enterprise switch when introduced to the local area network is detailed along with an understanding of the handling of the unicast and broadcast type of frames. So how does the switch handle this type of frames? To demonstrate how switches enable networks to overcome performance obstacles of shared networks. So by the end of this chapter, you should be able to. Cynthia, you can help us.
Explain the decision-making process of a link layer switch and configure parameters for negotiation on a link layer switch.
Exactly. So let's do it. So this device here is called a switch. A switch can be used to interconnect multiple end devices. Now, advantages of a switch compared to a hub or a bridge is number one, scalability. So a switch will provide us with many ports which we can use to connect end devices. Number two, what you call it actually eliminates or let's say breaks the collision domain into multiple collision domains. So what that means is once you have your switch here, if you're using, for example, 10 base T, then a collision can occur here. A collision can also occur here because it can send and receive over the same wire pairs. A collision can occur here and there. Please note that I've said that is when you're using 10 base T. With 10 base T, the same wires that are used to transmit are the same wires that are used to receive. Now, when you use what you call 100 base T, some wires are dedicated for sending and the others are dedicated for receiving. What does that mean? 10 base T uses half duplex. While this guy can comfortably use full duplex. So when you're using 10 base T, we can't even have collision occurring anywhere here. So it's important to remember that. And what is the other advantage of the switch? It greatly reduces the number of broadcast packets. Actually, is it broadcast? Yes, it's broadcast. It is able to reduce the number of broadcast packets within our medium, because you remember when we have the bus topology, because now with the switch, we are having a star topology. When you have the bus topology like this, can you still hear me? Something happened and I'm wondering. You can still be able to hear me?
Yes, yes.
Yes.
Okay. So when you have a bus topology like this one here, when one guy sends a packet, like this guy sends a packet or a frame, everyone else will receive it. So it will come like this, and everyone else will receive that particular frame. You see that kind of communication, it's quite cumbersome. On the other hand, when it comes to switches, when you send a packet to the switch can be able to forward data directly to the device that you are sending to. So this guy will not even receive that particular frame. This guy will not receive it. It will be sent directly to the person who is intended to. So we can send directly to this guy, unlike in this kind of arrangement where everyone else receives the data. So the switch uses what we call the MAC address table to forward data. The MAC address table to forward data. So it has this table, the MAC address table. Now, every host that is interconnected with a switch must have both the IP address, the layer 3 address, and the MAC address. Even though practically the switch only forwards using the MAC address, but we're going to understand why we need the IP address a little bit later. So this is what we call the MAC address table. The MAC address table has two columns, one column for the MAC address and the next column for the interface via which that particular device is connected to. So the MAC address is used to create an association or a mapping between the MAC address of a device and the interface via which it has been connected to. So for example, let me just write the last three parts of this particular MAC address for host A. So it is 0304 AA. So that is the MAC address for host A. Which interface has it been connected to? It has been connected to the interface G0/0/1, like that. So the MAC address will be populated bit by bit until it is able to know where every device has been connected. So that is the forwarding table for a switch. So in this particular example, when host A actually sends a frame, when host A sends a frame to switch A, then the first thing switch A is gonna do is to update. It's gonna update the MAC address of host A together with the interface via which it has been connected to, G/0/1, like that. So in case anyone else sends a frame, for example, host B, then it's also gonna update. It's gonna update. So 0304 BB. In which interface have we interconnected this device? We've interconnected it via G0/0/2. So how is this done? Now, in particular, the initial state of the switch is that it will have an empty MAC address table. So we've not learned any MAC address. So we'll only learn a MAC address once a device sends a frame. So let's see how that is done. Okay, so in this particular example, host A wants to send a packet. Is it to host B or host C? I'm not really sure, but I think we're going to see where it goes to at the coming slides. In the meantime, let's assume that host A wants to send a frame to host B. So the very first thing host A will have to do is to find out, do I have the MAC address of host C? So it will begin by checking its own ARP cache table. If that entry is not there, then host A will generate a broadcast ARP request packet with the destination MAC address of all Fs. The source MAC address is going to be the MAC address of host A. Now, when the switch receives this particular frame, the switch is going to update its MAC address table with the MAC address of host A and the interface via which it has been connected, G001. So that's how it's going to learn about the association of the MAC address of host A and the interface via which it has been connected on the switch. Okay, so let's move on. So because this is a broadcast packet, the switch is going to forward it with the destination MAC address of all Fs. The switch is going to forward it to all the hosts that are interconnected on all the other ports other than the port from which it was received, because this particular broadcast packet was received on this interface. So it's going to forward it out through all the other ports. Now, once that happens, this guy is going to check the ARP header. The ARP header will have an IP address in its destination IP address or network address field. So when it checks that and sees that, hey, my address is actually not matching with what is here, it's going to discard that frame. On the other hand, host C here will check the contents of the ARP header and see that its IP address is matching, and therefore it's gonna discard, it's gonna process and discard the Ethernet header and go ahead and process this particular ARP header. So when it processes that ARP header, of course, it's going to respond with what we call an ARP reply. An ARP reply. As you know, an ARP reply is a unicast, because this device already knows the IP and the MAC address of host A. So you can see the destination MAC address is the MAC address of host A. So once the switch receives that, again, just like it did with switch A, it's gonna update that particular entry of host C, the MAC address and the interface via which it has been connected to in its routing table. So after that happens, the switch this time is gonna check its MAC address table. Who is this that has the destination MAC address of this? So if it has it, then it's simply going to forward out that particular frame via that interface which that device has been connected to. And in this case, it is going to send this frame out through the interface G/0/1. So the switch is not going to forward to this guy. Not going to forward that particular frame to that particular person. So it's important to realize that this guy is not going to receive that frame. It's going to send directly because it has that entry in its MAC address table. So that is very important to understand, because really that is how a switch forwards what we call unicast packets. Unicast packets. Just a few things to mention here again. You might ask yourself, you remember we talked about the ARP cache table, that every host has an ARP cache table, eh? And we said that the entries of the ARP cache table are actually temporary. They stay for like 30 seconds or something. So you might ask yourself, what about the entries of the MAC address table of a switch? How is it treated? Is it permanent, or what really happens? So the thing is, the entry is actually permanent because, number one, if we disconnect host A from this particular interface, then the status of this interface will go from up to down. Anytime the status of an interface changes from up to down, what happens is the switch, is going to delete that entry of that particular interface in its MAC address table. So that is the first scenario. Now, what if now we connect this particular device to a different interface? What if we connect it to a different interface? Anytime we connect a device to a different interface and we configure an IP address, anytime we configure an IP address to an end system, we know that the end system will usually generate what we call the gratuitous ARP. So we know that the gratuitous ARP is actually simply an ARP request, which is a broadcast. So anytime you send the ARP request, which is a broadcast, then the new entry will be added on the MAC address table. So for example, hapa kama tumeconnect host A sasa kwa G004. So once ikituma tu hiyo ikituma hiyo gratuitous ARP, then its MAC address, allow me just to enter the last 3 bits of that. So its MAC address will be updated in the ARP table together with the new interface via which it has been connected to. So maybe G0/0/4. And that way, most of the time, the switch will always be able to maintain the current and correct association between the MAC address of a device and the interface via which it has been connected. So I hope that is clear. Now let's see some of the configurations that you can do in order to enable the switch to work in a particular LAN, local area network. As I mentioned earlier, you can use 10 base T. When you're using 10 base T, you're talking of half duplex communication. I've already explained that. When you use more current media like 100 base T, then you're using full duplex. Now, in order for you to be able to communicate with a switch, a number of parameters have to be configured. Some of these parameters include, and they have to match between the switch and the end device. So one of them actually is the duplex mode. The other one is the rate. So rate is simply the transmission speeds. And lastly, we have what we call the flow control. The flow control. So let's see what is happening here. So we move from the system view. We move from the user view to the system view. Then we get to that particular interface that is connecting to host A. So we get into the interface view of gigabit Ethernet 0/0/1. Then we have this first command here, undo negotiation auto. Undo negotiation auto. Now, these parameters here can either be configured manually. These parameters can be configured, number one, manually or automatically. Automatically is the switch interface and host A interface negotiate. They negotiate these parameters and agree on the duplex mode, the rate, and the flow control. Now, when you want to disable automatic negotiation, you use the command undo negotiation auto. Undo negotiation auto. So here we are disabling auto negotiation so that we can do manual configuration of those parameters. So in this particular case, we are specifying the duplex mode as full, and we are also specifying the rate using the command speed, then 100, which should mean 100 megabits per second. Hope that is clear. So in this next slide, we can just check to confirm. We can check to confirm what we've configured under that interface by using the display interface command. So when the negotiation is successful, negotiation of those parameters, then the line protocol state will change to up. When you connect that interface to another interface like we've done here, we've connected host A and this interface, then the physical status will change to up. But line protocol will only change to up if these particular parameters are actually set up. So here we can see what we just configured. The speed is 100, duplex mode is full, and we've disabled disabled auto negotiation. Okay, so that is it about the introduction. That is it about the introduction of the switch. So I want you to take a moment or two, go through this question. If you are unable to answer it, just refer to the answer and the explanation that is below it. Anyone with a question before we end it and move to the next chapter?